Hello students, this is Nirmal. We are going to continue the chapter natural numbers and whole numbers. This is the part 4 of this chapter. And in the last session we have talked about the properties of whole numbers for the addition. Today we are going to continue that topic, properties of the whole numbers, but today we will talk about the properties for the subtraction. First property is there, closure property. If x and y are any two whole numbers, then x minus y is not necessarily a whole number. X minus y may be whole number, x minus y may not be whole numbers. So it is not compulsory that if x and y are two whole numbers, then x minus y will also be whole number. No, it is not compulsory. It is not necessary. Through examples we can understand it. Suppose that x is equal to 8 and y is equal to 3. Then x minus y is equal to 8 minus 3 is equal to 5. Very good. Here we have got the what? The difference of the whole numbers, which is also a whole number. X minus y were the whole numbers. And x minus y is also a whole number, that is 5. If we will take the numbers 7 and 11, okay, x is equal to 7 and y is equal to 11, then x minus y will get 7 minus 1, it means minus 4, which is not a whole number. Sorry, here not is missing, okay, which is not a whole number. Here we will write not, okay, minus 4 is not a whole number. Whole numbers are not negative. So here we have seen that x minus y is whole number here, and here it is not a whole number. So x minus y is not necessarily a whole number. It means we can say that whole numbers are not closed under subtraction. Okay, if we would get the same type of number, okay, as a result, then we would say that yes, it is closed. But here we are getting the different type of number also. We have taken the whole number, but result we have not got the whole number. It means the subtraction of the whole numbers is not closed. Okay, now the second point is commutative property. Second property, commutative property. In addition, what we have studied that we can change the order of the whole numbers in the addition. Okay, we would we have taken like this, that 2 plus 5, then 5 plus 2, both are same because the result is 7. Result or sum remains same. 2 plus 5 is equal to 7 and 5 plus 2 is equal to 7. Even we have changed the order of the numbers. Okay, here 2 plus 5, but here 5 plus 2. We have just changed the numbers. We have interchanged the position of the numbers. Even then there is no effect on the result. So whole numbers are commutative, okay, under addition. But what about subtraction? Here we are talking about the subtraction today. So here we can say that if x and y are two whole numbers, then x minus y is not equal to y minus x. It means if we change the order of the numbers, then the result will be different. The result will not be same. Okay, so for example, we can take that two numbers 7 and 6 I have taken. Okay, two whole numbers 7 and 6. So 7 minus 6 if we will get, then 1, and 6 minus 7, then minus 1. Here we have changed the order of the numbers. Earlier 7 minus 6 was there, now 6 minus 7. Then what happens? Then here the results we got, they are different. Okay, it means 7 minus 6 is not equal to 6 minus 7. So we can't change the order of the numbers in the subtraction. Okay, so we will say that the subtraction of the whole numbers is not commutative. If result would be same, then we could say that they are commutative. Okay, if we change the order, even then the result remains same. It means the operation means addition, subtraction, multiplication, division, okay, that is commutative. But here for the subtraction it is not possible. If we change the order, then the answer differs. It means the subtraction of the whole numbers is not commutative. Okay, now associative property. Third one is the associative property. For subtraction we are talking about. So if we will take three whole numbers, then what happens? That in the addition we would be able to change the grouping of the numbers. Okay, but in the subtraction we can't change the grouping of the numbers. Suppose that x, y, z 3 whole numbers are there, then we can't say that x minus y minus z whole. Okay, whole of y minus z is equal to, okay, means this is not equal to this. If we change the grouping here, means x, y, z are in the subtraction, but the grouping are changed. Here y and z, okay, are in one group, means we have made the group of y, z, and here x will be here x should be, okay, x and y. So here what will happen, that the result will not be same if we change the grouping of the numbers. Okay, if we are going to change the grouping of the numbers, earlier these two numbers were in one group, now these two numbers are in the one group, then answer will not be same. So let's understand through the example. Suppose that x is equal to 15, y is equal to 10, and z is equal to 7. So for this, for group 1, okay, here x will be there, typing right there. So x minus y minus z whole, okay, x minus whole of y minus z is equal to x is equal to 15. So 15 minus 10 minus 7, y is 10 and z is 7. So if we solve it, then what will get? 15 minus 10 minus 7, 3. Okay, so 15 minus 3 is equal to 12. But if we'll change the grouping of the numbers, now we'll take the group of x and y. Okay, then what will we get? X minus y whole minus z, it means 15 minus 10, x and y, 15 and 10 they are. So 15 minus 10 whole minus 7, then is equal to, what will we get? 15 minus 10 is equal to 5 minus 7, then we will get minus 2. So what we have got, that if we have changed the grouping of the numbers, then our answer also we have got different. Okay, we have got the different answer. So we will say that x minus y minus z whole, okay, whole of y minus z is not equal to z minus y, x will be here, okay, x minus y whole minus z, okay, means this is not equal. So we will say that subtraction of whole numbers does not satisfy the associativity, means addition of the whole, subtraction of the whole numbers is not associative. If it would be equal, result would be equal even after changing the grouping of the numbers, then it would be said that subtraction of the whole numbers is associative. But here we are getting the different answer. They are not equal answer. We have not got the same result even after changing the grouping of the numbers. So we will say that subtraction of the whole numbers are not associative. Now existence of identity. So if I'll say that which number should be subtracted, or from which number any number should be subtracted, then we will get the same result. Okay, so there is no number. Even if we take the 0, then x minus 0 is equal to x, but 0 minus x is not equal to x. We don't get that same result, means it lose the identity. Okay, so identity does not remain same. So we will say that for subtraction no identity number exists. For addition it exists. That 0 is the what? Additive identity we have studied in the previous session, that x plus 0 is equal to x and 0 plus x is equal to x. Even 0 we will add to any number, or any number will be added to 0. We will get that number only. It means the identity remains same. But in the case of subtraction it does not. It is not same. Okay, we will get the different answer. So for subtraction no identity number exists. When 0 is subtracted from itself, then we will get 0. So 0 is the identity of itself. Only 0. Okay, only 0. What? 0 is the identity of itself. 0 will get subtracted, then we will get the 0. So for 0 only it is same. Okay, but rest of the numbers it is not same. I hope that you have understood. So in today's session this much only. We will continue the properties of whole numbers in the next session. Till that time, all of you, bye and have a nice day.